Please take your calculator, all of you. Mesh analysis for AC circuits. This concept we will take with an example. In the circuit shown below, determine V2, which results in zero current through the 4 ohm resistor. Use mesh analysis method. So this is the given network. In this network, V2 is represented here. We have to find the value of V2, but because of this V2, the current flowing through the 4 ohm resistance, which results in zero current, which is flowing through 4 ohm resistance. Hence, the current flowing through this branch, the branch containing 4 ohm, is zero. So we have to use this value, and we have to find the well, V2 value. So this is the given network. So is telling that use mesh analysis method. So first, once again, I'm going to resketch the given network as same thing. I resketched and I represented the polarity plus minus and plus minus, and this is the first loop. I represented the loop current I1. Similarly, second loop I represented the loop current I2. The last loop, that is loop number 3, with the loop current I3. And for all the loops, the respective branches are there. For the branches, I represented the polarities. Okay, now first, I2 is 0 because the current flowing through the second loop is represented by I2, that is 0. The current I2 is 0 because the I2 represents the current flowing through the loop number 2. But see, in the second loop, 4 ohm resistance is present. In the question itself, it is given that uh, there is a 0 current flowing through the 4 ohm resistance. Hence, the whatever the current is flowing through this branch, that is 0. It is given. So in this branch, current I2 is flowing. Because of that reason, current I2 is 0, as the current through 4 ohm resistance is given to be 0. So apply the KVL to the first loop. minus 5 minus 5I1 minus minus J2I1, and the arrow mark at is pointing here, hence plus 50 of angle 0 volt, that is equal to 0. So for the simplification, I will take the coefficients of I1 common. Taking I1 common, minus I1 have taken common. If I take minus I1 from this one, left 5. From this I taken minus I1 common, left plus J2, that is equal to, take this term towards RHS, hence it becomes minus 50 of angle 0 volt. Hence I1 equal to, minus minus get cancels, I1 equal to 50 of angle 0 volt divided by 5 plus J2. So the numerator term is in the polar form and denominator term is in the Cartesian form. So it is impossible to simplify because both are not belongs to same parameter, same term. Numerator is polar and denominator is Cartesian. Because of that reason, simplification is not possible. So what I am doing here, I am converting this Cartesian to polar form. Then I am going to do the simplification. Then how to convert Cartesian to polar? So there is a very simplest method is there. Conversion from Cartesian to polar. C stands for Cartesian. P stands for polar term. C to P, nothing but Cartesian to polar. Cartesian is of the form x plus jy, and polar is of the form r of theta. R stands for magnitude, theta stands for angle. How to convert the values from Cartesian to polar? In the calculator, so I will take this value, that is 55 J2 is there, 5 plus J2 is there. So I will take here, shift plus, you will get polar. So what values you have to type here? 5 comma, the imaginary value is 2, hence 5 comma imaginary values 2, bracket complete. Then press equal, you will get the 5.385, it is the magnitude value, hence 5.385 it is magnitude value. Then in the calculator, press alpha f, f is written here, then press equal, you will get 21.801, it is of angle, 21.801 it is of angle, hence we converted 5 plus j to Cartesian form to polar form, 5.38516 angle 21.801 degree. So these are the steps. Plus in the calculator, press shift plus, will get the pole of bracket, then you have to enter 5 comma imaginary value 2, then press equal, you will get the magnitude value. Then next step is press alpha f, and we'll get the, after press alpha f, once again you have to press equal symbol, then you will get the angle. So this is the step for conversion from Cartesian to polar. So we got this answer, 5.38516, 21.801. Next is simplification. 50 by 50 divided by 5.38516. So answer is 9.2 9.247, 9.2847, and angle is 0 is there, 0 minus 21, hence it is minus 21.801. So we got current I1 as 9.2847 of angle minus 21.801. Okay, this is the simplification. Next, similarly, apply the KVL to the loop number 3 for this one, that is minus 2i3, minus 2i3, then minus v2, minus v2, next minus of minus j2i3, minus of minus j2i3, but in this branch one more current is flowing, that is i2, i2 is flowing, but i2 is already known, that is 0, so leave it. So next simplification, I will take this minus v2 other side, it becomes plus v2. Then take I3 common. If I take I3 common, then we left minus 2, minus into minus plus j2. Hence v2 equal to I3 multiplied by minus 2 plus j2. So further simplification, I3 equal to v2 divided by minus 2 plus j2. So from this loop number 3, we got current, that is I2, but I3 is we didn't calculate it. Then how to calculate I3? So simple step I will tell. Before that, before calculation of that value, I'm going to tell one more parameter, one more point. See, node A and node B I represented. In between these two nodes, one branch is present. That branch has 4 ohm resistance. But through this branch, whatever the current, that is current I2 is flowing, that current is 0. If this current is 0 means it is what? Open. So node, whatever the current is present at, whatever the voltage is present at this node is equal to the voltage present at the node B. So we can say that VA equal to V suffix A equal to V suffix B. So see this one, as current through 4 ohm resistance is 0, the nodes A and B are at equal potential. So we can write VA equal to VB. So voltage across that branch, VA means voltage across this branch, voltage across this branch, and VB means voltage across this branch. VA equal to VB means, see, I am going to write here, VA is equal to VB. Okay, fine. What is the value of VA? So in this branch, two currents are flowing, that is minus I1, correct? Minus I1 and plus I2 multiplied by J2. Okay. Similarly, coming to this branch, in this branch, minus I2, minus I2, I3 is pointing plus, plus I3 multiplied by the term, the branch having the value that is minus J2. So I2 value is already we know the I2 is 0. I2 is 0. Hence substitute here. Hence we got minus I1 J2 is equal to minus in I2 is what? 0. Leave it 0. So I3 multiplied by minus J2. Hence minus I3 J2. Hence what? Minus minus get cancels. I1 J2 is equal to I3 J2. Don't cancel J2 J2. Okay. Next we have to calculate I3. I3 is already we calculated. I3 is what? I3 is equal to V2 by minus 2 plus J2, and as well as I1 is calculated. Substitute these two values in this expression. I1 is how much? 9.2. 9.2. Here you have to substitute the value of I1, that is 9.2847 of angle minus 21.801 multiplied by J2 is equal to I3 is what? I3 is V2 divided by minus 2 plus J2, V2 divided by minus 2 plus J2 multiplied by J2. Okay. So this is the step. Then how to simplify this one? Okay. Same thing I written here. Here. Minus 9.28477 minus 9.28447, then minus 21 angle. Same thing we got here. Up to this step we got same thing. Next is how to simplify this one. Okay. This step we have to simplify. Very simple. See here. Now I'm going to convert J2 to this is Cartesian form. I'm going to convert this Cartesian to polar. So here J2 means what? J2 means J2. We can write 0 plus J2 because real part is 0. So let us convert this Cartesian to polar. So in the calculator, shift plus. So what is the value? Real part is 0, comma. Imaginary part is 2. Bracket complete. Equals how much you got? 2. So 2 is magnitude. What about angle? Now to calculate angle, press alpha F, then press equal, then 90 degree. So 90 degree is the answer. So we converted this Cartesian to polar. 2 of angle 90 degree, that is equal to V2. Same thing. J2 is already calculated. That is J2 is what? 2 of 90 degree divided by 2. This one we have to convert minus 2 plus J2. This is the Cartesian form. Once again, I'm going to convert to polar form. Shift plus. What is the answer? Minus 2 is there. Minus 2 comma plus 2. Plus equal. How much we got? We got 2.828. 2.828. Then press alpha F equals 135. Angle is 135 degree. So this minus 2 plus J2 Cartesian is converted to polar form. Then further simplification, very easiest simplification. 2 of angle 90 degree, 2 of angle 90 degree, both are get cancels. Else V2 equal to 9.2847, 9.28477 multiplied by 2.82, 2.8284 is equal to 26.2610, 26.2610. So next angle multiplication. So 90 you take sorry, minus 21 here, 135 is there. So 135 minus 21. So how much you're getting? 114, approximately equal to 114. So here I have not considered the fractions. I will consider fractions here. 135 minus 21.801. So 113.199. So 113.19. Hence we got the answer. We calculated the value of V2. Let us take one more example for mesh analysis for AC circuits. Here in this example we calculate the voltage. In the next example we are going to calculate current. Find the current through the 4 ohm resistance. Same circuit I have taken here, same network I consider here. But see, in the same example is there. Same example I consider what we calculate 26.26, right? 26.26 of angle 130 nothing but you subtract this from 180 will get minus 66.8. Okay, same circuit I consider. Here in the previous example we represented this voltage source as a V2 and we calculated the value. Same thing I substitute here, but what we assumed, the current flowing through the 4 ohm resistance, we assumed that I2 is 0. Same thing here we have to calculate. Answer is we know because same circuit is there. Find the current through the 4 ohm resistance by using loop current method, or we can say mesh analysis method. Same circuit is there. Also, already we know the answer that the current flowing through the 4 ohm resistance I2 is 0. So let us verify the answer. First, I will apply the KVL to the loop 1. Minus 5I1. Next, minus J2I1. In the same branch, one more current is flowing. That is plus J2I2 plus 50 of angle 0 degree is equal to 0. Let us take the coefficients of I1 here. I will take this I1 coefficient, that is 5. If I take minus 5 minus I1 common, 5 plus 5 plus J2. Otherwise what I did here, I have taken this term, this entire term towards RHS. So plus 50 of angle 0 equal to, this becomes minus, becomes plus, plus minus. Now we can say that I1 coefficients 5 plus J2 bracket complete minus J2 I2 is equal to 50 of angle 0 degree. Next, similarly apply the KVL to the loop 2. So what is that? Minus 4 I2 minus of minus J2 I2. In the same branch one more current is flowing, that is plus of minus J2 I3. Then coming to this branch minus J2 I2. In the same branch one more current is flowing, that is plus J2 I1. Let us verify. Okay, apply the KVL to the loop 2. We got same thing. Answer is same. Now I'm going to take coefficients of I1, that is J2. Then coefficients of I2, 2 are there, that is minus 4. Minus into minus plus. Here plus J2 minus J2 get cancels. Minus into minus plus J2. Here minus J2 is there. Plus J2 minus J2 get cancels. Only one term, that is minus 4. Then coefficient of I3 minus J2 is equal to 0. Represent as the equation number 2. Similarly, apply the KVL to the loop 3. That is minus 2I3 plus 26.25 of angle minus 66.8. Then coming to this branch, minus of minus J2 I3. In the same branch one more current is flowing, that is plus of minus J2 I2. Let us verify. Yes, we got same thing. Next, rearrange the terms and rewrite and represent it as equation number 3. So if the values are entries are very simple in the real part, then using calculator we are going to calculate the determinant as well as unknowns. See, we got 3 equations. Equation number 1, 2, 3. The 3 equations, there are 3 unknowns: I1, I2, I1, sorry, I1, I2, I3. There are 3 unknowns are there. In each and every equation, there are 3 unknowns: I1, I2, I3. So, but in these 3 equations, the values are given in terms of Cartesian form, in terms of polar form. So it is impossible to calculate by using calculator directly. So what we are doing here, we are making use of Cramer's rule here. So first I will find, so what we have to calculate, we have to calculate I2, the current flowing through the 4 ohm resistance. In that 4 ohm resistance current I2 is flowing, so we have to calculate I2. I2 equal to what? D2 by D. So D, first we have to calculate determinant of the matrix. So first I am going to calculate D. First row entries will represent the coefficients of I1, I2, I3 of equation 1. Second row entries will represent similarly coefficients of I1, I2, I3 of equation 2. So you can verify. Coefficient of I1 is J2, coefficient of I2 is minus 4, coefficient of I3 is minus J2. Similarly, coming to equation 3, there is no I1 term, 0. Coefficient of I2, J2. Coefficient of I3, minus 2, sorry, 2 minus J2. Okay. Likewise, we have to write the determinant. Then further simplification, I will explain here. Plus minus plus 5 plus J2 inside the bracket. Leave this first column and first row and multiply these two entries. Minus 4 into 2 minus J2, minus of minus into minus plus J2 multiplied by J2, J square 4. Next, coming to this one, minus of minus, it becomes plus. So J2 as it is. Leave this row and leave the second column entries, and J2 multiplied by 2 minus J2. Okay, minus 0 multiplied by anything is 0. Leave it. And coming to last one, 0 multiplied by anything is 0. So hence it is 0. Next, further simplification, 5 plus J2, minus 4 into 2 minus 8, minus 4 minus into minus, it is plus. J2 into 4, J8, 4 into 2, 8, J8. Next, J square is minus 1, so minus 4. J2, J2 into 2, that is J4, minus as it is, J square 4. Next, coming to here, 5 plus J2, minus 8 minus 4 minus 12 plus J8, J2 as it is, 4J. J square is minus 1 into minus, it is plus 4. Then 5 into minus 12, it is minus 16. 5 into J is 8 into 5, 40, 40J. Next, take this value, J2 into minus 12, minus 24J. Next, J into J, J square, 2 into 8, 16, plus J square, 2 into 4, 8. So 2 into 4, 8, J8. Further simplification, minus 60, J40, minus J24, J square is minus 16, J square is minus 8, plus J8. So hence real part, minus 60, minus 16, minus 8. That is 60, 16, 8, 84, minus 84. Then 40 minus 24 plus 8, it is plus J24. Hence we calculated determinant. So the thing is that we have to calculate the current flowing through the 4 ohm resistance, that is I2. I2 equal to D2 by D. So no need of calculation of D1. So directly I'm going to calculate D2. How to calculate D2? Second column entries of matrix. Second column entries of D are replaced by the constant. Constants are, that's right. First 50 of angle 0 degree, 0, 26.25 of angle minus 66.8, 26.25 of angle minus 66.8. So remaining as it is. Similarly, how we simplify this determinant? Similarly, if you simplify the D2 value, you will get the answer. You get the answer D2 equal to 0. Hence, current flowing through the 4 ohm resistance is given by I2 equal to D2 by D. D2 is 0. 0 divided by anything is 0. Hence, current I2 is 0 amperes. Likewise, we have to solve uh, loop analysis for AC circuits.